Hey there, educators. If your child or the students in your classroom are struggling with multiplication facts, I want to share something that was created specifically to build understanding. The Seeing Patterns Building Power series is designed to help students make sense of multiplication before we ever rush to memorization. Two books are currently available on Amazon: Seeing Double, Making Sense of Two Equal Groups, and Seeing Nothing, Seeing the Same, and Seeing More, Making Sense of Multiplication with 0, 1, and 3. These books aren't drill sheets disguised as stories. They're visual, conceptual experiences that help students see structure, recognize patterns, and build fluency in a way that sticks. Because when multiplication facts become automatic through understanding, students free up their cognitive load for more advanced topics like ratios, algebra, functions, modeling. Fluency becomes a foundation and not a hurdle. You can find both books now on Amazon. Just search the titles or my name to grab your copies. And one more thing I am especially proud of: my 16-year-old son recently released his first book, Anansi: Shadows of Myth and Mystery. If you have a reader who loves adventure, mythology, and a little bit of mayhem, this is a story they'll want to dive into. Support young mathematicians, support young authors, and let's keep building power one page at a time. Hey there, educators, and welcome back to the Make Math Happen podcast. I'm your host, Lanisha, and today we're talking about the major work of eighth grade, and that is functions. It is not a side topic. It is not an extension. It is the main character, or at least one of them. In eighth grade, students are expected to define, evaluate, and compare functions and use functions to model relationships between quantities. Before we say slope, before we write equations like y equals mx plus b, before we graph anything, we need to understand the thinking that students have been developing over time. Functions didn't begin in eighth grade. Sure, the language is new, but really functions is the formalization of reasoning that started years ago. So let's zoom out, as I like to do at the beginning of our episodes, and think about what we've been building up to this point. In December, we focused on seeing math. So we zoomed in on geometry, looking at structure, space, and movement. In January, we shifted to understanding math. So now we're looking at number systems, thinking about magnitude, distance, and composition. And then last month, we connected math through ratios and proportional reasoning. We talked about how two quantities vary together. Now we step into modeling. And to solidify this step, I want us to take it back to sixth grade for a minute. In sixth grade, students begin to represent and analyze quantitative relationships between dependent and independent variables. So if I have any sixth grade teachers listening, I want you to think about when you started teaching dependent and independent variables and how you helped your students be successful. So during this time, you probably used things like ratio tables, double number lines, coordinate planes. The idea of dependent and independent variables, although it may come at a different time in the year, it is directly connected to ratios. And we know that ratios are those multiplicative relationships between two quantities. They are not calling this idea of function, but they are already exploring covariance. They are noticing that when one quantity changes, another changes with it. That is the seed of functional thinking. In seventh grade, students recognize and represent proportional relationships between quantities and identify the unit rate or constant of proportionality. So if you're a seventh grade teacher and you're listening to me right now, you know that students have to understand that proportional relationships graph as straight lines through the origin. That point, 1R, represents the unit rate. The equations can model those relationships. This is where we sharpen our multiplicative reasoning as we are moving towards that proportional reasoning. We formally move from unit ratios, sixth grade, to unit rate or constant of proportionality. Okay, we are really building on there. We are becoming a little bit more sophisticated, if you will, but it's all connected, right? They are identifying the constant relationship that governs a comparison. So now when we compare that work to what we want students to do in eighth grade, there is a critical shift. Proportional reasoning is when two quantities vary in tandem, whereas functional reasoning is when two variables vary in tandem. In proportional relationships, that graph passes through the origin, the relationship is purely multiplicative. But in linear functions, there may be an initial value, additive and multiplicative reasoning may coexist. Slope represents the constant rate of change. Functional reasoning asks students to coordinate magnitude, scale, direction, structure. They're abstracting information. And this is when you think about that CRA model, this is when it can become really challenging for students because now they're starting to symbolize relationships a little bit more. Because in seventh grade, we're looking at y equals kx, right? But in eighth grade, we're now building on because that initial value may not be zero. So there is more to manage here. And that's why students who struggled with ratio reasoning often struggle when they get to eighth grade and move into functions. Functional thinking builds directly on proportional reasoning, which builds directly on multiplicative reasoning. So if those students have not solidified their understanding in those areas that helped us get here, then when they get here, they're going to struggle here. So I want you to really think about that. And that's the whole purpose behind this series is I wanted to emphasize the relationships across the domains that we're teaching, because I think that in the connections is a way for us to help students who come to us with unfinished learning reach grade level proficiency. Okay. Now, will they reach grade level proficiency this year? Maybe not. But if every single teacher in every grade level really emphasize the connections across these domains and help those students to use what they know, right? Because students come to us knowing some things. If they help students use what they know and they connect to what they want them to know, we can get a little closer every single year. Okay. So what is a function? The standard definition says a function assigns to each input exactly one output. But that definition alone doesn't necessarily build understanding for our students. So sometimes we got to ground it. No, not sometimes, all the time. So I want you to think about a recipe, and I shared this in a previous episode. If I follow that recipe exactly, same quantity of ingredients, can I accidentally produce something entirely else? No, the output is predictable. It's about a consistent rule that is governing how these variables are varying in tandem. So it's not about students memorizing a formula. We really want students to understand the relationship here. What is the relationship between the ingredients in this recipe? And the context may not be about cooking, but they have to understand that whatever it is that we're discussing, it's working together. It's working together. So when we think about the representations that students are using, we're talking about one relationship really, but we can represent that relationship in many forms. So a function can be represented as a table. We can map it. We can graph it. We can create an equation. And then obviously we always have that real world context that students have to then abstract that information and then symbolize it or represent it using one of these other forms. These are not separate topics. They are different lenses for viewing the same relationship. And this is where geometry kind of returns. This is where I get excited about the connections, because when we think about spatial reasoning, it really shows up here when we're talking about representing functions. Graphs require spatial reasoning. Axes require magnitude and scale. Number sense returns too, right? Understanding how values change depends on understanding magnitude, understanding the rate, understanding how quantities scale. If number sense is fragile, graphs feel confusing. If geometric reasoning is weak, slope feels abstract. It feels out of reach. If ratio reasoning is underdeveloped, functions feel procedural, okay? And we don't want everything to feel so procedural. Now, obviously, we know when we're talking about rigor, there has to be the presence of the conceptual understanding, the procedural skills and fluency, and the application. We need those things there. So that's not to say that procedural skills and fluency don't have a place, because they absolutely do. They are a leg on the stool. But what we do want to understand is procedures is not just a set of rules that we want students to follow blindly. We want students to think about the connections within those procedures that they're following. We want them to think about, as they are performing a specific skill, we want them to be efficient, we want them to be accurate, and we want them to be flexible. That is the fluency. And so when we think about functions is really another opportunity for all of the ideas across those other domains to really converge, to kind of meet in one place. So this is what it looks like in practice. If you're introducing functions this week, I want you to think about, before jumping into equations or graphing, I want you to ask your students to describe the relationship in writing. Yeah, we got to bring back some writing, okay? And then after they write it, I want you to allow them to turn and talk to a peer so that they can verbally discuss the relationships that they noticed. How are the things connected? Before they write the equation, ask them what's changing, what stays constant. How do you know? Before they graph it, ask them to predict the shape of the graph. Then you can cycle into your representations. And then as students are talking, make sure that you're listening through the lens of the standards for mathematical practice. Are students making sense of the problem? Are they reasoning abstractly and quantitatively? Are they looking for and making use of structure? Are they expressing regularity in repeated reasoning? Functional reasoning is not about producing equations quickly. We want them to be able to model relationships precisely. Okay? So here's the big idea. A function is the formal language for describing how one variable depends on another in a consistent way. Students have been building towards this since elementary school. They've been comparing quantities, scaling relationships, identifying unit rates, recognizing constant multiplicative structure, representing relationships graphically. Geometry gave them structure. Number systems gave them magnitude. Ratios gave them covariation. Functions formalize that covariation. Next week, we'll explore how proportional relationships become linear functions and how slope is simply the constant rate of change students have already been reasoning about for years. So it's the same story, just a little bit more abstraction and a deeper structure. I'll talk to you soon.